Okay, so we have discussed all the theorems related to this chapter. We have discussed two theorems, two most important theorem for this chapter. Now, based on this theorem and the questions that we have done according to this with these theorems, let us discuss the practice sheet of circles. The practice sheet of circles, let us discuss these first 9 questions. After that, we will discuss other questions also. This sheet contains more than 30 questions for the practice purpose. So, we will discuss these questions. Okay, so the practice sheet question number 1, it's very simple question. Question says, how many tangents can a circle have? Okay, so question 1 is, how many tangents can a circle have? एक सर्कल पे कितने टेंजेंट्स पॉसिबल हैं? दिस इज व्हाट वी नीड टू आइडेंटिफाई. सो क्वेश्चन नंबर 1, लेट अस से दिस इज अ सर्कल. ये एक सर्कल है. इस सर्कल पे मुझे टेंजेंट ड्रॉ करना है. अब टेंजेंट ड्रॉ करने के लिए क्या इंपॉर्टेंट है? टेंजेंट ड्रॉ करने के लिए सर्कल के ऊपर एक पॉइंट इंपॉर्टेंट है. ओके, मुझे एक पॉइंट को मार्क करना पड़ेगा इस सर्कल पे. रैंडमली मैं कहीं पर भी एक पॉइंट इस तरह से मार्क कर देता हूं. Let us say this is A point. Now, can I draw a tangent at this A point? Yes, it's very easy because a tangent is a line segment which touches the circle at single point. So this line segment touches this circle at a single point. So this is a tangent. Similarly, if I choose a point B at this location, can I draw another tangent? Yes, I can draw another tangent like this. If I choose a point C like this, I can again draw a tangent. If I choose a point D like this, I can again draw a tangent. So the number of ways I can choose different points on the circle is the number of ways I can draw tangents. जितने तरीकों से मैं इस सर्कल के ऊपर पॉइंट्स को सिलेक्ट कर सकता हूँ, जितने पॉइंट्स मैं सर्कल पे सिलेक्ट कर सकता हूं, उतने ज्यादा टेंजेंट्स मैं ड्रॉ कर सकता हूं. सो जस्ट फोकस कि मैं इस सर्कल पे कितने पॉइंट्स सिलेक्ट कर सकता हूं. पॉइंट्स दैट आई कैन सिलेक्ट ऑन दिस सर्कल आर इनफाइनाइट. दिस कैन बी अ पॉइंट, दिस वन, दिस वन, दिस वन, एंड ऑल दीज पॉइंट्स कंटेन infinite number of points in between them. So if I can choose infinite number of points on this circle, then I can draw infinite tangents to this circle. Okay, so the answer for first question is how many tangents can a circle have? So a circle can have infinite tangents. A circle infinite tangents. A circle can have infinite tangents. Okay, so this is the first question. It's very simple question, but yes, it is important for the discussion. Second question is fill in the blanks. The first subpart of this question is, a tangent to a circle intersect it in dash points. A tangent to a circle intersect it in how many points? A tangent can intersect a circle only at one point. Okay, so question number 2, first part is 1. The first fill in the blanks. The answer for the first blank is 1. Okay, ONE 1. It means a tangent can touch a circle only at single point. Multiple points पे एक tangent touch नहीं कर सकता. हाँ, मैं multiple points निकाल के multiple tangents जरूर बना सकता हूँ. Okay, so let us discuss the second one. A line intersecting a circle in 2 points is called. So this is what we have studied in the introduction part of this chapter. एक ऐसी line जो circle को 2 points पे intersect कर रही है, उसे हम क्या कहेंगे? That line will be known as secant. Okay, secant. Secant is a line which intersects the circle at 2 points. Third fill in the blank. A circle can have dash parallel tangents at most. Okay, so this question says how many parallel tangents I can draw. How many parallel tangents I can draw to a circle. So let us discuss this part. if I have a circle like this, okay, this is a circle, this is the center, and let us say I draw a tangent at this point. I draw a tangent at this point. Okay, so a tangent parallel to this tangent can be drawn only at the other end of this line. Now, what is this line? This line is basically the diameter of the circle. Why it is the diameter? Because it passes from the center. Okay, it passes from the center, hence this chord, this line is a diameter. What I have done is, I have drawn, this is the circle, I have drawn a radius perpendicular to this tangent at this point, and I have extended this radius up to this point. Okay, so I can draw another tangent at this point like this, and this tangent will be parallel to the first tangent. Now, why this tangent is parallel to this tangent? It's because if you observe properly, this, let us say this is O, this is A, and this is B. This OA is the radius of the circle because it passes from the center, and A is the point of contact of circle and the tangent. That's why I can say that this angle is 90 degrees. Okay. Now, similarly, this OB is the radius of the circle. This B is the point of contact of circle and the tangent. Okay. So, this OB angle, this angle is also 90 degree. Okay. This angle is also a 90 degree angle. Now, observe it very carefully. This is one line, this is second line, and this line, this AB line is a transversal. And you can see that this angle plus this angle, these two angles, the sum of these two angles is equals to 180 degrees. Okay, the sum of these two angles is equal to 180 degrees. Now, try to remember what you have studied in lines and angles. If I have two parallel lines like this, and this is a transversal, then the sum of internal angles, okay, the sum of internal angles, these two angles, is equal to 180 degrees. The sum of these two angles is equals to 180 degrees. That means these two lines are parallel. Okay, and here also what we are getting that sum of these two angles is equals to 180 degree. That's why I can say this tangent and this tangent are parallel. Now, can I similarly draw any another tangent that is parallel to these two tangents? No, I cannot draw. I can draw various secants like this. These are the secants, but only two tangents can be drawn which are parallel to each other, not multiple tangents. And the reason is very simple. The sum of interior angles of these two parallel lines and the transversal is equal to 180 degree. It can happen only once. Okay. So question says a line intersecting a circle can have dash parallel tangents at the most. So the answer for this question is a circle can have two parallel tangent at most. Okay. Maximum it can have two parallel tangents. It is not possible to draw three tangents parallel to each other, because if you draw any tangent from any other point, that tangent will not be parallel to any of these tangents. It will intersect the two tangents. Okay. So this is the third one. Then fourth one, the common point of a tangent to a circle and the circle is called dash. So what is the common point? What is the name of this common point of this tangent and the circle? The common point, the name of this common point is point of contact. Okay, it is known as the point of contact at which this tangent is drawn, this one. So this is the solution for second question. It's very simple. Okay, so now let us discuss question number 3. Question number 3 says a tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at a point Q, so that OQ is equals to 12, then length of PQ is. Okay. So the question says, question number 3, question says a tangent PQ at a point P of a circle. Okay. So the first 3 or 4 words says that there is a circle, and on this circle there is a center and a radius of 5 centimeters. Okay, the circle given has a radius of 5 centimeters. Then a tangent PQ at a point P of a circle. So P point is on the circle. So there is a point P on this circle. Let us say this is the point P. This is the point P. It says at this point P I have drawn a tangent. If I draw a line, a tangent at this point P, it will be drawn like this. So this line is a tangent at point P. Okay, PQ is a tangent, but we don't know the location of Q. We don't know where exactly the Q point lies. So this is what we know till now. A tangent PQ at point P of a circle of radius 5 centimeters meets a line through O, through the center O. It means the center of this circle is O. Okay, so this tangent meets a line through O. So from this center, if I draw a line, that line will meet this tangent at point Q. So if I draw a line at this point from the center, it will meet this tangent at point Q. So PQ is a tangent. This is what is given in the question. Okay. Then it says length of OQ. So that OQ, this OQ is equals to 12 centimeters. Then find the length of PQ. So what is given in the question is that there is a circle with center O. There is a point P on the circle, and from this point I have drawn a tangent. Okay, there is a tangent at this P point. After this, what I have done, I have drawn a line from this center O to this tangent such that this line intersects the tangent at point Q, and the length of OQ is 12 centimeters. Okay, this is what given in the question. So now what you need to do is you need to determine the length of PQ. So how to determine the length of PQ? Let us first join this P point with the center. This is OP, which is the radius of this circle, and since at point P this line is a tangent, PQ is a tangent and OP is the radius, so from theorem 1 I can write that angle OPQ is equals to 90 degrees. So what we have is that OP is equals to 5 centimeters, OQ is equals to 12 centimeters, and we have OP perpendicular to PQ by theorem 1. Okay, from theorem 1 we have OP is perpendicular to PQ. Now since OP is perpendicular to PQ, observe the triangle OPQ. In triangle OPQ, this triangle, you have this angle as 90 degree. So if angle P is 90 degree, I can apply Pythagoras theorem to this triangle. So by applying the Pythagoras theorem, OQ square is equals to OP square plus PQ square. Okay. Now what is OQ? OQ is given as 12 centimeters. So OQ is 12 centimeters. 12 square is equals to OP square is 5 centimeters. So 5 square plus PQ. This is PQ square. Okay. So OQ square is 12, OP square is 5 centimeters, and PQ square is as it is. Now 12 square is 144, 5 square is 25. So when you shift this 25 from RHS to LHS, you will get PQ square is equals to 144 minus 25. And what is 144 minus 25? It is equals to 119. So PQ square is equals to 119. So the length of PQ is equals to square root of 119 centimeters. Okay. So the answer for this question is square root of 119 centimeters. The length of PQ is square root of 119 centimeters. So this is the solution for the third question from the practice sheet. Okay, first note this, then we will continue. Okay, now let us solve question number 4 from the practice sheet. Question number 4 says, draw a circle and two lines parallel to a given line such that one line is a tangent and the other line is a secant. Okay, so the question is very simple. Question number 4, it says draw a circle. So first you need to draw a circle. Let us draw a circle like this. So this is a circle and two lines parallel to a given line. Two lines parallel to a given line, it means there is a line given to us. Let us say this is a line given to us. What you need to do is draw two lines parallel to this line. This is a given line. We don't know which kind of line is this, okay, in which direction it is heading. Just we have drawn a line. Now we need to draw two parallel lines, two lines parallel to this line such that one line is a tangent to the circle and another is a secant. So this is, let us say, L, which is given line. Okay, this is given line. So if I draw a line parallel to this line such that it is secant to this circle, then I can draw a line like this. Because what is a secant? Secant is basically a line which touches or which intersects the circle at two different points. So this line intersects the circle at two different points. This S is the secant. Okay. And similarly, can I draw a tangent? Yes. A line which is parallel to this line but touches the circle at single point is a tangent. So this is a tangent. So this is the question that we have to do. Okay. This is all about question number 4. इससे ज़्यादा इसमें कुछ भी नहीं करना. It's very simple question. You just need to draw two lines which is parallel to this line. One is a tangent and one is a secant. Okay. So this is the solution for fourth question from the practice sheet. Let us discuss question number 5. Question number 5 says, prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. Okay, so question number 5 says that there are two concentric circles. So let us first focus on this particular line, that there are two concentric circles. So what are concentric circles? The circles which have same center are known as concentric circles. Let us say this is one circle and this is another circle. So these are the two circles, the two concentric circles, and this is the center. Let us say the center is O point. This O point is the center of both the circles. Okay. Now what it says is the chord of the larger circle. So you can draw many chords on this larger circle. Like I can draw a chord like this. This is a chord. I can draw a chord like this. I can draw a chord like this. Okay. There are many chords that I can draw for this larger circle. Now it says the chord of the larger circle which touches the smaller circle. You can see if I observe this chord is a chord of the larger circle, but it do not touch or intersects the inner circle or the smaller circle. If you see this chord is a chord of the larger circle, but it intersects the inner circle at 2 points. So what I can say about this chord? This chord is basically a chord for the larger circle, but it is a secant for the inner circle. Okay, this is the secant for the inner circle because it intersects this circle at two different points. Now, then what about this chord? This is a chord for the larger circle, but you can see this chord is touching the circle at one point, at single point. That's why I will say that this line is a chord for the larger circle but a tangent for the inner circle. Okay, this is how the question is explaining. Okay, so which touches the smaller circle. Okay, so what we need to do, we need to consider only the chord which touches the smaller circle. So let us remove all the chords which are not of any use for us. Let us remove these two chords, the chord which is secant and the chord which is neither secant nor tangent. So we need to consider only this chord. So this is a chord which touches the circle. We need to prove that this chord is bisected at the point of contact. This is the point of contact, let us say P. Okay, let us say the chord drawn to the larger circle is AB. So AB is a chord and this chord is a tangent to this inner circle at point P. So what we need to prove is that AB is bisected at point P. Bisected means AB is divided into two equal parts at point P. That means AP is equal to PB. That is what we need to prove. Okay, this is what we need to prove. So for proving this question, let us write the given conditions first. We will follow the same procedure. So the given conditions is, the first condition given is two concentric circles. Okay, then second condition is the second given condition is AB is a chord to larger circle and tangent to inner or smaller circle. Okay, at point of contact is P. You can write here also that P is the point of contact, or even if you do not want to write, it doesn't matter. Okay, so this is the given condition. Now what exactly we need to prove? To prove, we need to prove that this AB is bisected at the point P, at the point of contact. That is, we need to prove that AP is equals to PB. This is what you need to prove. Okay, so let us start this proof. Now, before starting the proof, let us join this OP, let us join this OB, and let us join this AB also. Okay, this AB. Now, as you know that OP is a radius of the circle and P is the point of contact of this AB tangent and the radius of the circle. For this inner circle, this is the radius. This is the radius of the inner circle OP, and this AB is the tangent at point P. So can I say, since OP is radius of smaller circle and P is point of contact and P is point of contact of circle, of this inner smaller circle and the tangent, therefore I can write OP is perpendicular to AB. And why OP is perpendicular to AB? Because of theorem 1. We have already understood theorem 1. So by theorem 1 I can say that OP is perpendicular to AB. So this angle is 90 degree and this angle is also 90 degrees. Okay. Now if you observe that OA is what? OA is basically the radius of the larger circle. And what is OB? OB is also the radius of the larger circle. So if I say OA is equals to OB, so why OA and OB are equal? OA and OB are equal because both are what? Both are radius of larger circle. Okay, radius of larger circle. Now this and this side are equal. These two lengths are equal. What we need to prove is this AP and PB are equal. So how to prove this AP and PB? You can see that here you can observe two triangles. यहाँ पर आपको दो triangles दिखाई दे रहे हैं. You can very clearly observe two triangles. The triangle AOP and triangle BOP. AOP and BOP, the two triangles that you can observe in the figure. Let us mark the two triangles. This is the first triangle and this is the second triangle. So these are the two triangles that you can very easily observe. In these two triangles, OA is equals to OB. You can see OA and OB are equal because they are the radius of the larger circles. Similarly, you can see OP is equals to OP. Now, why OP and OP are equal? It is common because it is common to both the circle. OP and OP are equal. And you have one more important condition, that angle OPA is equals to angle OPP. And why the two angles are equal? Because each angle is 90 degrees. Now, since this OP is perpendicular to AB, I can say angle OPA, this angle, and OPB and this angle are equal because both the angles are 90 degree. So you can see that in these two triangles are basically right angled triangle at this angles. इन दोनों angles पे ये दोनों कैसे हैं? ये दोनों triangles right angled triangle हैं. And what is OA? OA is the hypotenuse. OB is also the hypotenuse. OP is basically the perpendicular or the side of this right angled triangle. So what I can write is, I can write that triangle OAP is congruent to triangle OBP. Reason is right hypotenuse side. They are congruent because of the criteria right hypotenuse side. The right angle is equal, hypotenuse OA and OB are equal, and the side is OP. OP is equals to OP. This is already we have written. So by right hypotenuse side criteria, both the triangles are congruent. Now since triangles are congruent, what I can have is AP is equals to BP. Why? Because of CPCT. CPCT is corresponding parts of congruent triangles. So AP and BP are equal. This is what we have to prove. AP and PB are equal. So since AP and PB are equal, I can very easily say I can write AB chord is bisected at point of contact. I can say that AB chord is bisected at the point of contact. Okay, and the reason is AP is equal to BP. This proof is very simple. You can see just the application of first theorem. Just I have used this first theorem once, and using that theorem I have proved this question. Okay, but you need to remember that this question also contains the concept of triangles that you have studied in previous class. Okay, the congruency of triangles. You need to use that congruency also. So this is the proof for this question, and we have solved question number 5. Okay, so first note this question, then we will solve the 6th one. Okay, let us now discuss question number 6 from the practice sheet. Question number 6 says, two tangents TP and TQ are drawn to a circle with center O from an external point T. Okay, so question says, there is a circle like this, and on this circle two tangents are drawn from an external point P, external point T. There is an external point T and two tangents are drawn from this T point, that is TP and TQ. So TP and TQ are the two tangents to this circle. So these are the two lines, and this is TP and this is TQ. TP and TQ are the two tangents on this circle with center O. O is the center of this circle, and it is given that, okay, so TP and TQ are the two tangents to this circle with center O from an external point T. You need to prove that angle PTQ is equals to 2 times of angle OPQ. This is the angle OPQ. Let us mark angle OPQ. So this is the angle OPQ, this angle. Okay. So this is the diagram for this question. It says that there is a circle with center O and T is an external point, and from this point we have drawn two tangents TP and TQ. You need to prove that angle PTQ, that is this angle PTQ, is equal to 2 times of angle OPQ. This angle is OPQ. You need to prove that this angle is 2 times of this angle. Okay, so before starting the proof, let us write the given condition. The given condition is, what is given in this question? The given conditions are O, a circle with center O, okay, then TP and TQ are tangents from point T. There is a point T from which we have drawn two tangents. Now, to prove, what you need to prove is, you need to prove that angle PTQ is equals to 2 times of angle OPQ, 2 times of angle OP and Q, this PTQ angle. Now try to think how to prove this angle, how to determine a relation between this angle and this angle. What should we do to determine the relation between this and this angle? How these two angles are related to each other? Let us think. You can see that basically this angle, we have already proved a theorem, a property in the previous question, that if you observe this angle, this particular angle, and if I join this O and Q, observe this angle and this angle. previously in a question we have proved that sum of these angles, sum of these two angles is basically equal to 180 degrees. Why it was 180 degrees? Because if you observe PTQO, this is a quadrilateral. In this quadrilateral, this particular angle is 90 degree and this particular angle is also 90 degree. And why these two angles are 90 degree? Because of theorem 1, that at the point of contact, radius and the tangent are perpendicular to each other. So this is what we have proved previously. So I am not going to prove it again. What I am going to do is I am going to use the same property that we have proved previously. So let us discuss those property. Here I am saying that sum of this angle and this angle is equals to 180 degree, that you should know. Okay, so let us start the proof. I am saying that angle PTQ is plus angle POQ is equals to 180 degrees. And why it is 180 degree? I am writing the reason that proved previously. Try to recall the question that we have done previously and we have proved the sum of these two angles equals to 180 degree. Okay. Now observe very carefully. I have a relation between these two angles, but my task is to determine a relation between this small angle and this angle. So this angle and this angle, how to relate these two angles? I have a relation between these two, and if you observe very carefully, I have a relation between this and this angle also. Between these two angles also I have a relation. How? Let us see this. If I say that suppose this angle, this P angle is x. Suppose this angle is x. मैं इसे x मान लेता हूं. Now, in triangle POQ, if you observe the triangle POQ, you can see that OP is equals to OQ. Why OP and OQ are equal? Because both are radius. Both are radius of the circle. Since in this small triangle, this side and this side are equal, I can say this angle and this angle must also be equal, because angles opposite to equal sides are equal. So if OP and OQ are equal, it implies angle, this one, OPQ is equals to angle OQP. This is what you will have, and the reason for this is angles opposite to equal sides are equal. Angles opposite to equal sides are equal. So if this angle is x, I can say that this small angle, this OQP will also be x. Okay, these two angles are x and x. Now, if you see this OPQ triangle, we know that the sum of internal angles of a triangle is equal to 180 degree. So in this small triangle OPQ, I can write x plus angle POQ is equals to 180 degrees. Now why I can write this as 180 degrees? Because sum of internal angles of a triangle is 180 degrees. Sum of internal angles of a triangle is 180 degrees. So from this I can get angle POQ is equals to 180 minus 2x. If I simplify this, I will get angle POQ is equals to 180 minus x plus x 2x. It will be shifted from LHS to RHS. It will become minus 2x. Okay. Now, let us say this was our first equation, and let us say this is our second equation. So, from equation 1 and 2, from equation 1 and 2, try to determine the relation, try to observe very carefully that this angle POQ can be substituted as 180 minus 2x in this relation. In place of angle, where it is? No, sorry, this is not first equation. This was first equation. I can substitute angle POQ is equals to 180 minus 2x in this relation. So what I will get? I will get angle PTQ plus 180 minus 2x is equals to 180 degrees. This is the relation that you will get. Try to observe very very carefully. Okay, मैं इसे स्लो ही बताऊंगा बिकॉज ज्योमेट्री में इट्स वेरी इंपॉर्टेंट टू रिकॉग्नाइज ईच एंड एवरी कॉन्सेप्ट, ईच एंड एवरी स्टेप. सो दिस PTQ प्लस एंगल POQ की जगह 180 minus 2x we have written this, and this is equals to 180 degrees. Now from this equation I can cancel 180 from both the sides, and I will get angle PTQ minus 2x is equals to 0, and angle PTQ is equals to 2 times of x. Now what is x? X is basically OPQ. This x angle is OPQ. So in place of x I can write angle PTQ is equals to 2 times of angle OPQ, and this is the relation that we need to prove. Okay, so hence proved. Now what you need to do is you don't need to mug up this solution. ऐसा नहीं सोचना कि एग्जाम में क्वेश्चन आ गया तो ऐसा का ऐसा लिख देंगे. Try to understand the steps. Try to understand the approach that I am using. What I have said previously, आपको इस एंगल और इस एंगल में रिलेशन निकालना है. तो इन दोनों एंगल में रिलेशन कैसे निकाला जाए? मैंने ऑब्जर्व किया कि मुझे इस एंगल और इस एंगल के बीच में एक रिलेशन पता है. कौन सा रिलेशन? ये वाला. और फिर ये सोचा गया कि अगर किसी तरह से इस एंगल और इस एंगल में रिलेशन निकाल लिया जाए, then I can very easily determine a relation between this and this angle. So this is the approach of geometry. Okay, this is like a hit and trial. You cannot mug up the concept and just directly apply. You don't need to understand, you don't need to learn that 2 plus 2 is equal to 4. Okay, so if there is a plus sign, you just need to add up. ऐसा हमेशा नहीं होगा. You will find different cases in geometry, and what you need to do is you need to apply your hit and trial method to solve the geometry questions. Okay, so this is a interesting question number 6. Okay, so first note this, then we will continue.